Hello? Can everyone hear me? Okay. Hello, everybody. Uh, my name is Philip Oko, and I'm with Adam, and we're part of RUSEC, and we'll be giving a malware analysis workshop, and we'll be starting now. Let's see. Let me just share my screen momentarily. And, okay. All right. So, like I said, we are part of RUSEC. Um, so, let me get it. All right. Uh, Hopefully everyone can see my screen. Someone tell me if otherwise, but we are part of RUSEC. Uh, my name is Philip Oko. I'm a senior at Rutgers, New Brunswick. I practice malware analytics. Adam, if you want to say something about yourself too.
Yeah, I'm a junior, and I'm mostly interested in game reverse engineering and file formats and stuff like that.
Yeah.
Also DRM and cracking and stuff like that as well.
Yeah. So we come from kind of two different backgrounds, I guess. I started in the cybersecurity malware and analytics scene. As they said, he came from game hacking. So already right there, you can see that reverse engineering is actually very big. But today we'll be focusing on malware analytics. That's the one we practice a lot at RUSEC, and it's the one we'll be doing today. Just from my end, I have a blog called mousescope.com. If you want to check it out, I do malware analytics stuff there. All right, so first things first, what is malware analysis? Malware analysis is a lot of things, but it can really be broken down to these three important aspects of it. Essentially, you're trying to get information out of the malware. You're trying to get its origin, basically who sent it, its behavior, their tactics and techniques. So this can encompass, first of all, how did they even make it onto the endpoint or the computer which you're trying to attack. Once they're on the endpoint, how are they gaining persistence? Persistence means how are they installing themselves? Like if you were to restart the computer, how do they allow themselves to be maintained on the system? Another thing that you're looking at is identifiable information. So identifiable information means information that is very unique to the piece of malware itself. This information is very useful. It's actually the most important aspect of malware analytics because this is the stuff that helps prevent attacks or earlier detections in the future. So this can be through what we call hashes, a cryptography-based hashes, to identify a piece of malware. It can also be used to say exactly, we can write YAR rules, or we can match it with certain events that pertain to that specific malware. And then in the future, if we see that same type of behavior or we see that same type of signature sometime in the future, we can say, well, we know that this is exactly what we've seen in the past. We can prevent it before it occurs again. But malware analytics is also a combination of many other things. So, for example, reverse engineering is the basis of malware analytics. Actually, reverse engineering is understanding a finished product with very little documentation. Uh, in malware analytics, you're dealing with pieces of malware, obviously, but because they're pieces of malware, there's no tutorial or handbook about that specific malware family to tell you exactly how it operates. That would be non-beneficial to the author of the piece of malware. So you might be jumping into something completely new. So it takes a programmer or a knowledgeable analyst to look at a piece of malware and determines behavior with very little knowledge about what it does. Most of the time, especially with newer pieces of malware, you might be going in blind. You also, a combination of programming. As you see pieces of malware, you start to see repetition and a lot of things that have been there before. So it's, you know, I think a really difference between a regular malware analytics actual version engineer versus a really good one really comes down to their ability to create scripts to automate the process for themselves. There's no point of redoing the same thing 100 times by hand when you can automate it and save yourself a bunch of time, especially in your career when eventually you're going to move on to maybe having to analyze 50 pieces of malware that were batch collected. Doing it by hand would just be too tedious. Uh, it also takes knowledge of programming languages in general. Uh, malware is written in code, so you're going to need tools to decompile or see the source code again. But if you can't read that source code, you're not going to be able to understand at all what's happening. So, getting familiar with, core programming languages such as C, JavaScript. Nowadays, languages like Go and Rust are becoming more popular in malware. So those are also beneficial malware uh, languages to learn about. Lastly, it's also a combination of research. Oftentimes, you're going to be looking at older implemented technology, but reading documentation on these older pieces of technology, it can take time and a lot of effort, and I want to say dedication to just be reading stuff that maybe isn't the most flashy stuff, but it's what's been implemented in the malware, or it's very crucial for how the technology works. So you have to put the time and effort to actually look into that. So research is a very important skill of malware analytics, and it's actually one of the things that most people overlook because, as I said, it's not the flashiness. It's not quick. It can take very long time, but it's definitely worth the effort. So as I said before, the main purpose of malware analytics is learning the tactics. We want to know how the malware gain entry, uh, what they use to gain persistence, and your methods used to steal data. This information can save, you know, whatever company you go to, thousands upon millions of dollars. Just knowing how a piece of malware operates and then being able to prevent future occurrences. So, what signatures does the malware give off? As an analyst, you're going to have to get better at determining these signatures. As malware authors are constantly changing their pieces of malware to bypass signature detection systems. Because of that, it's crucial for you to build signatures that are very resistant to small changes to programs, like just changing a byte, which would completely change the hashing algorithm, the hashing function output. I mean, so yeah, I just wanted to give a little talk about what malware analytics is. I think I got interested in malware analytics my sophomore year of college. Uh, but realistically, the foundation on which I built that on was just my knowledge of um, programming languages and software development, and then eventually operating systems, and so on and so on. Because malware is just code, and how they manipulate the operating system in ways to maybe hide themselves or steal certain information. So the more you know about computer science, the better you're going to be at malware analytics. So I think anyone can get into it, but I think it takes a little bit more dedication to just maybe self-teach yourself certain aspects of it, because not everything is neatly documented, especially when you're looking at malware research or exploits that malware have used. Not everything's uh, documented in such a way that it's just easily accessible or quick and easy for you to just get. Uh, but with that, I kind of want to move away from just talking, and Adam will be leading the demo.
Yep. Hello. I don't have a webcam or anything, but I'll just talk. So okay, let me share my screen now then. Okay, hopefully this is visible. So this is the OVA file that Philip shared in the malware workshop chat. So if anyone wants to follow along, you can just go to that chat there and download the OVA and try. Just wait for it to power up for a second. But this is basically a VM with a bunch of common tools on it, and then also with one malware sample. These tools you can find on the internet. They're all freely available. We'll be using a couple of them in our analysis. So some of the most common ones are pinned down here: Detected Easy, Resource Hacker, Ghidra's up here. There's some sysinternal stuff. And then the malware samples, there are a few different places you can get them on the internet. There's like a couple GitHub repositories that have them. There's also a site called Malware Bazaar. That's probably the most, like the most act one, like has thousands and thousands of samples. But yeah, you can just go on here and download pretty much any malware you want. But the particular sample we're going to be looking at, it's an older piece of malware, but it is a good beginner malware to look at because it uses some techniques that are interesting, but it's not very obfuscated, so it's easy to understand, which means that for our analysis work, it's a lot easier to see what it's actually doing versus hiding itself from what it's doing. So from the start, when you first open the malware sample, you just have this. You have these two files, and the two files are the same. I'm not sure why the archive came with both of them. I guess this is just the original, or maybe this is just the hash, and then this is what the original file was before it was renamed or something. But anyway, it's an exe file. You don't want to run it. Starting out with our analysis, we don't know really anything about what it does except the name that previous analyst team gave it, which was Win32 Info Stealer. So it's probably some kind of spyware. And one of the first tools that I like to run when analyzing malware like this is Detected Easy. This is a tool that that you can basically drop your executable on, and it'll tell you a bunch of different information about it. So a lot of this info here, like the compiler and the linker, it's not necessarily important info for every piece of malware, but it is nice info to have. Compilers have specific ways about how they lay out the executable. And there's also valuable things here like strings. You can see there's a lot of Windows functions in here, API functions. It seems there's also a lot of duplicate strings. You could see that that entire set of strings here is just duplicated again and again. But every time they're duplicated, they're not exactly the same, but they're very similar. So that could imply that this was linked statically, and then every time the same string was written down, it, instead of pointing to the same address, it just made new strings. But we can look through that later as we analyze the code. There's also, but the good news about the strings, the fact that we can see like readable strings like this somewhat implies that there's at least some code in this executable that is not encrypted or packed or compressed, which is good. However, that doesn't mean that the entire executable isn't. And that's where probably the most useful part of Detected Easy is the entropy, where you can look at this. So entropy is basically a way of telling how random the data is. And this is the scale here of the randomness. And then this is basically just how many bytes into the file you are. So you can see code is usually somewhere between like, I don't know, 5 and 7, somewhere around there. Usually it's closer to like 4 or 6, around this point. Basically, it's not the highest, but it's not low either, because there is a large variety of instructions that you can use, so it's fairly random, but it's not completely random. There are some instructions you'll never see, or some bytes that you won't ever see because they aren't instructions. Whereas data sections are usually lower entropy, especially in executables where there's lots of like either zeros or Fs or just blank spaces where there's not a lot going on. You can sometimes see entropy as low as like 0 or 1 or 2. And resource sections should be around the same as data. They should be down here. But as you can see, the resource section of this program is actually, oh, and actually here, the relux shows, relux section has low entropy, just like the data does. But the resource section has the highest entropy of the file, which is not normal. And so Detected Easy even shows, based off of this entropy value, which is over 7, it claims that it's packed, which means that this has had some kind of either compression or encryption algorithm applied to it, which makes almost every byte look completely random, and therefore it's probably one of those things. So the resource section is a part of the executable that's used for storing files used by that executable directly. So for example, actually in Detected Easy, you can see this little icon up here. That icon image is stored in this resource file for this executable. And so usually that's what it's for, is just icons and, you know, the name of the file. And sometimes simpler programs, they might put like dialog boxes in there and things like that, but it's not meant to store other things, but you can store other things in it. So the fact that there's some kind of packed data in there heavily implies that this is a dropper of some kind, which means it drops another piece of malware that then runs things. So with that in mind, we can now start actually analyzing this using, oh, well actually, yeah, so another tool that we have on here is Resource Hacker. And so since we found that the resource section is an area of interest, we can actually dump the resource section and, well, dump files within the resource section and inspect what they are. So if it wants to load, we can take a look at this executable and see what actually is in it. Okay, so yeah, so you can even see it calls itself an icon. But then if you go here, this is not an icon. It doesn't show an image. And if you switch to binary view, this right here, MZ cannot be run in DOS mode. This is obviously a Windows executable. So one thing you might notice though is that you see how it looks like there's somewhat readable strings, but they're not completely readable to multi-at byte. Like, why is that at there? You know, or this even up here, this program cannot be run in DOS mode. Like, why is the space? Well, that implies that this is not a raw executable, but it had some kind of compression or encryption applied to it, which makes sense given that it's supposed to be packed. Which actually, that means this is a pretty terrible, if the intent is obfuscation, this is a pretty terrible obfuscation method, because you can obviously tell that it's executable code, even if it's meant to be hidden. But anyway, so we can dump this and save it to a file. So you just save the resource to bin file or whatever, and you can call it whatever you want. So I'll just call it drop.bin for now. And so, oh, that's one other thing I would strongly recommend, just so you don't accidentally run it. You should rename the executable to remove the .exe part. So that way, if you double click it by accident, it's harmless. So now we have two files that we can investigate. So I'm going to pull up Ghidra. And actually, I should say we can't investigate this second file directly yet because we don't know how it's packed. So putting this in Ghidra would be pointless because it wouldn't the format. But we can analyze the first original dropper. Okay, and so going into Ghidra, usually the default settings are fine unless you're analyzing like some, console program or malware for like ancient computers or something. But usually it detects Windows and Linux executables pretty well, so there's no point messing with the options. You just say okay, and then you gotta wait for it to import. And you can see, we noticed before all those Windows API strings, there's a lot of different DLLs that it accesses. So that's actually one of the things that makes this particular malware easier to analyze. Is almost all of the functions that it calls are external DLL API calls, which are not obfuscated at all because it calls the function by using its real name. So that means even though this is a stripped executable, like 80% of the function calls we know the name of because they're all known APIs. Yeah, so now when we open it, whenever you open pretty much anything in Ghidra, you just want to run the auto analysis. And again, usually these default settings are completely fine. So you just analyze. And this is a pretty small executable, so it finishes pretty quickly. So open the functions list while it's working. You can see there's about 81 functions here, which is actually very tiny for an executable. I've seen executables with tens of thousands of functions, but still for an analyst, that's 81 functions that you have to sit through and figure out what they do one by one by one. And you can also see a couple of these, because this is a stripped executable, so most of them do not have function names. But every once in a while, you get to something like this where it is, and it's a single match. So this is Ghidra attempting to identify what a function is based off of the hash of its bytes. It's not always the greatest, unfortunately, in Ghidra. I mean, obviously it says library Visual Studio 2019, but we know that this malware is at least as old as 2013. So unless this function hasn't changed at all in 6 years, it's not the Visual Studio 2019 version. And the function name might not even be the same if the APIs have changed over the years and stuff. So the other reason that it's not great, as we'll find out later, is that the Ghidra function ID often misses things, like very obvious things I've found. But we'll get to that shortly. So one thing that we can do is in either the functions list over here or in here, you can see the entry. So entry is often it depends on your executable. Some executables that actually have a main like they're supposed to, the main is where you want to start. But if you can't find the main, a good way to find it is to follow from the entry. But as we'll see in a second, there is no main here. It just starts its code in its entry point, which to me at least implies that they heavily messed with the compiler settings, and they probably did some assembly or something in order to get, because they essentially completely replaced the start function with this. So it's the first code to run when the executable starts. But yeah, and again, as we can see, all Windows API functions, almost all the way down. There are some functions like this that are local functions. And here's where we actually get to, I mentioned that Ghidra doesn't always mention or notice C library functions. If we rename this to be easier to read for a second, it's a for loop using parameter 3 as the length, and it's taking every value of parameter 2 and adding it to parameter 1. Well, actually, that's not true. Parameter 2 has no things. It's not a pointer. But it's taking parameter 2, whatever that is, and setting every single byte of parameter 1 to be equal to it. And so I don't know how well you guys are familiar with C, but to me, this is obviously memset. So this is the array that you want to set values of. This is the value you want to set it to, and this is the length of the array. So that's like a static C library function that's used all over the place. And because it's statically linked, it did get stripped, unlike all these other things. But that's what I mean. Like, we don't want to always spend time analyzing functions that are library functions because the known behavior already. But in a case like this where Ghidra doesn't identify it, you kind of have to. But we can do an informed analysis of this malware because we know from before that it drops a resource. So while there are probably other important things that this executable does, the most important thing for our analysis right now is to figure out how does it get the resource, what encryption is used on the resource, so how can we unpack it ourselves, and then how does it interact with the resource? Like, is there any malicious functionality of this executable itself, or is all the malicious stuff in the thing that's dropped, or do they communicate with each other? There's all kinds of ways it could work. So instead of just scrolling through and trying to read this right now, start with, since we know that everything is a API function anyway, and you can actually see if we go to strings that like every Windows API function has its name somewhere because that's how it has to be accessed in the DLL. So like a DLL and then the name within the DLL. So since every single one has it and it's using a Windows resource, that means it's probably using a Windows function to access said resource, which means that we can search program text. We have to include defined data values like all these strings. And then what we can search for is resource. And we'll find resource A, size of resource, load resource, lock resource. All of these are, and here we go. Here's the actual pointers to the DLL. But what's useful here is the pointer is referenced by a function. So now we have the code that accesses the resource. So you can see that it finds a resource, gets the size of it, loads it, locks it, allocates memory for it, and then it creates a file for it, writes to the file, closes the handle, frees it. So essentially taking its resource and then dumping it. Now you will see this right here. This is a function call also, but it's a function call that's determined on the fly from a pointer. And Ghidra handles these pretty weirdly, but we can double click on it and see where it was set. And it was actually set in the entry that we skipped analyzing. But if you look at, hold on, what was the name of this? F74. So if we scroll for F74, right here you can see these get proc addresses. So this is where it accesses the DLL and it gets the API call name on the fly. This is another way to do DLL accessing, just like I showed before with the resource functions. That's one way, directly with a pointer, and this is another way, calling get proc address. But since we know what these do now, we can just rename all of these globals to the proper name. And then it looks like in particular F74 is the one that was called decompress buffer, RTL decompress buffer. So that means that that is the function that would decompress the packer used on actually, you know what? Just copy it instead. That means that's the thing that would decompress the packer used on the resource, which means that we can go and decompress that resource right now. Now, there are a couple ways to go about doing that. The main way is, of course, just calling RTL decompress buffer. You could do this in a debugger, like you could just run the one line that does the decompression, or you could look up and see what kind of scripts there are to do this. So if we use the internet for a second, we can RTL decompress buffer, and we'll see that it uses this LZNT1 decompression. Well, actually, you can see it has multiple compression formats. But if we go back to where it was called in the other function, which parameter is this now? This is the first parameter, u short. If we do set equate, and then we do, oh, it doesn't have it here. Okay, that's fun. 5, 6. Okay, well, I guess one possible way to do this would be to actually look at the DLL and see which or what values are set to each of this bit mask. But oh, you know what it is? I know what it is. It's if you switch to binary, it's a bit mask, right? It said it's a bit mask. So you can see this is a 1 and that's also a 1. So what that really means is that this is two different things and then it was ORed together, and that's why it's not noticed. Because if this was just 1 here with zeros all the way down, it would detect it, and if it was just 1 here with zeros all the way up, it would detect it. But since there's 2 1s, it doesn't know what it means because it was an OR between 2 of these. But anyway, the point is, it's LZNT1. That's what it does. So we can look up LZNT1 decompressors. There are some Python scripts that do it. I'm not a big fan of Python personally, but this would be a way to go if you like Python. You can just pip install this and then decompress it that way. But if you do a little bit more research, there's people online who before have run into this format and asked for decompression tools, and then you can see some other tools that were written for it. This is just a Windows command line tool to do it, which is pretty much exactly what we need. So we can grab the resource, or not the resource, we can grab the release for it. And then it's usually good practice when downloading executables from the internet like that to run them in VirusTotal then, but I've already done that before, so I know this is safe, but you really should not just run exes without doing that. Okay, so now we can drag and drop this in here, and where we have our dropped bin, we can make a decompressed version of it. So I'm just going to open a command line in here. I just realized I didn't actually read the documentation for this, so I should run it and see how it works. Okay, so I just have to run it and pass in the compressed file, and then pass in a file name for decompressed, and that's all I have to do. So it should be win33 dropped up in, and then do like win32 3 dropped decompressed up in. There you go, and you can see it definitely decompressed it because it's a larger size. So that's all we need from that now. And so actually, we can go back to here and start analyzing the second file. Since if we open it in a hex editor, you can see that the thing we noticed before of all those random bytes in between is gone. It's now fully readable. There's no random bytes everywhere, and it looks like a fully valid file. So another thing is if we go up one from where this function is called, the thing that drops it, you can see that it loads the library that, well, actually, it drops it and it renames it secure DLL. But then also, when it goes up, then it loads the library DLL. So the relationship between these two is very clearly that this is a DLL file and this is an exe, and this it calls the DLL. So we can now rename this to DLL. And well, actually, I'm going to do that thing I said before now, making it an underscore so you don't run it by accident. And you can do the same thing here also. And so then we can start analyzing the DLL file in conjunction with our actual executable. So again, we just run the auto analysis. This is actually more complicated than the initial function. You can see there's 100, well, it's still searching for them, but there's at least 180 functions and probably more. Okay, yeah, there's definitely 186. But then once the analysis goes, you can see almost all of these are actually statically linked C functions. And I'm honestly not sure why Ghidra identified them this time and it didn't identify them before. Like, you can even see memset here, and memset is, I mean, it's operating a little differently than the other one. Maybe this is because the Visual Studio way has a bunch of other safety checks that the other one didn't. But if you want to write your own memset, it is literally the way the other one worked. So maybe, maybe these malware authors just re-implemented some of the C library for fun, or else it just didn't detect it properly. But anyway, so the analysis finished already. You can see the vast majority of these are static C functions. You don't need to analyze. There are a few here that aren't, that it looks like do things registry related. And actually, if you looked through the other file a little bit, you would see the same registry keys mentioned in the other file. So very clearly, both files do something important. And if we go back to the exe, once it loads the library, it does two things. It gets the process address of 1 and 2. And we talked about get proc address before because that's what was used to get that decompressed buffer. But you don't have to pass a name into it. You can pass a number, and the number is just the ordinal number of your function. And it just so happens that the malware authors here mentioned the ordinal number of the two functions that it loads. So like they literally named the functions ordinal 1 and ordinal 2. Which means that this is now ordinal 1, and this is ordinal 2. And it also means that those are probably the two most important functions here, because I would bet that every other unnamed function is just called by one of these two, and the rest of these are not called at all. Or if they are called, what I mean is they're not called directly. They're C functions that were necessary for compilation. So here we can see some interesting things, getting the keyboard state, keyboard layout to ASCII. Like that, to me, obviously seems like a keylogger. It's reading in user input and just logging it. And if we scroll down a little bit, there's some interesting stuff going on down there as well. We can go to ordinal 2, and again, get keyboard state stuff. Entering sections. Yeah, this looks like getting a file, writing to the file. It's taking the keyboard input it read, and then it's writing it to a file. So it looks like this DLL is primarily a keylogger. And if we go back to the exe, we can start looking at the rest of the things it does. So actually, here you go. You can see where it writes the two logs, strokes even. It calls it strokes. Like that's your keystrokes. I'm not sure what temp.log is for, but so now we can start looking at the rest of this then, since this is what we haven't looked at yet. So going back to the entry, other than setting up the process addresses like we went over before, it does a lot of stuff regarding setting mutexes. Mutexes are a common malware thing where it basically means mutually exclusive. And so the idea is that it can only be set once, and once it's set, then it's there. And so then the point is you make a mutex, and then you check if mutexes are there. And if they're there already, then you don't create the mutex, you just leave. So it's sort of similar to a header guard. If you program in C, a header guard is there so that you don't include the header multiple times. Or if you do, it only actually does the copy paste once. And this is the same idea. It's basically so that if if this malware has run there previously or other similar malware is already running there, then don't bother with this one too, because they're going to conflict. That's the main idea of it. For real software that isn't malware, mutexes are often used for making sure you can only run one window once or something. I can't think of an example off the top of my head, but there are definitely programs that do that. They don't want you running multiple instances. So then we can scroll down a little bit more. There's stuff about getting folder paths for iexplorer.exe and stuff like that. That could imply that maybe it copies itself into another executable or injects code. That's possible. You can scroll even further. And by the way, I should mention, I haven't been doing this whole time because it's not a fun demo, but you really should be keeping notes the entire time you do malware analysis work. You want to have a notepad file or a some kind of fancier note-taking thing, and you want notes. Screenshots are good too, but you should document what your thoughts are the whole time, why you think those things, all this stuff. Because then later, when you're writing up your analysis report, or if you're making a blog post on it or something, you have something to show for your work, and you don't have to re-go through it. And it also means if you have to stop analysis for one point and then you come back to it later, you know where you left off. Anyway, there are a lot of interesting things here. You can even see registry keys being set for like the Java security plugin. You can see there were other functions before. You can see I don't remember where I saw it, but there are functions in here where you can see like Windows security settings being reduced, basically, where like I think it adds exes and DLLs and stuff to the safe files in the registry. So basically, essentially it's getting rid of are you sure you want to run this file? Yes, no. It's getting rid of that prompt saying always run exe files when prompted. So that way it can call other things in the background, and you won't get any UVA prompts or anything. I'm trying to find where it does that. Uh, well, anyway, I'm not going to do a complete analysis of all of these functions here because we don't have time, but we did go through the most important, the most interesting things. I guess if anybody has any questions, I'd be willing to answer or go through those now. I don't know if I don't know how those would be relayed to me. Maybe if you have questions, you could type them in the malware analysis workshop channel, and I'll uh, try to address them. But if there aren't any questions, I'll just keep looking for the thing I was talking about.
If any questions do arise, I can let everyone know, but I don't see anything at the moment.
Okay, thank you.
Yeah, so as Adam is looking for this, I also, want to give a little about like kind of this malware. So this was actually the first malware I've ever analyzed. Just to like give some more context, with the malware analysis, as you saw with Adam, there's a lot of steps to it. So he had the initial analysis phase, and he was essentially just trying to, see where to look, because when you're looking at malware, especially when you don't have any documentation about it, it's essentially a black box. And you don't want to go down a huge rabbit hole on something that, might not even be useful. So what Adam, did initially at first was use Detect Easy to essentially give himself a microscope onto where to look and where's the most interesting pieces. So that when he uses a tool like Ghidra, he knows exactly where to get the information and get more information so that he can do more analysis later. I think, with Adam too, with the knowledge he's built up, um, he's able to make a decision very quickly on where to go. But that's what really it takes to be a malware analytic. So, we have these tools like Ghidra. For those who don't know, Ghidra is what we call a decompiler. It was created by the NSA, but they released it. But these tools are only as useful as the analysts themselves. So Adam obviously knows exactly where to look with the tool. But if you don't know where to look, it can be as useless as not having the tool at all. So I just want to make that point clear that while we're showing you the tools and everything like that, it's really just to gauge your interest of what malware analytics looks like. But it's really more about understanding how these functions work. And Adam looked at the MSNDN documentation for Windows, and you get more information on certain functions. So that's really what malware analytics is really about.
Yep. Okay, so I didn't find what I was looking for, but I did find one interesting thing actually. You can see here, because I mentioned before this is spyware, and you can see here this is where it connects to the IP address that it was sending information to. It also seems to have a URL that it could connect to also. I guess if it can't connect to this. And then it sends HTTP requests there, and it uh, sends sends stuff, and then waits for responses and stuff. So this is very much sending probably the keylogged information and probably anything else it can find about your computer. But yeah, so if that was if we didn't come into this knowing it was an info stealer, the oh wait, where was it? It's just there. That function I was just looking at, the one that sent all the internet stuff, that would be a very good indicator that this is some kind of spyware. Um, yeah, you can see other things too involving like internet code stuff. In fact, I would bet this is called by yeah, that same function I was just looking at. Okay, yeah. Um, but the other thing of interest is I'm not sure why Ghidra does this. It makes like because there's all kinds of DLL files here that we went over before, and most of them it just treats at pointers, and then some of them it creates thunk functions for, and I don't understand why it does that. But really, these like why doesn't it do it for all of them or none of them? Like it only does it for some of them. It's weird. But anyway, yeah, all of those near the bottom you can actually ignore. So um, those are kind of pointless, and the C functions, as you identify them, you can ignore them as well. So there's probably really only about 40 functions in here that do anything useful. And oh wait, that function that it was just looking at, this one, again, this is obviously another C library function. You can see, oh wait, we were just on that one, is alpha. But there are other obvious C library functions in here, like this one. This is one of them, yeah. But there was a better example. This one. Yep, this one. This is another C library function. Is digit. And you can tell it's is digit because it checks if it's like you might get confused, like you're like, what does it mean to be less than a char or greater than a char? Well, what it means is that these are ASCII codes, right? And so basically what it's saying is that there's 0 through 9, which are between each other. And then if it's anything other than 0 through 9, then it's not a digit. And if it isn't anything other than 0 through 9, then it is a digit, and then it returns Boolean. So again, this should have been caught by Ghidra, and it wasn't.
Okay, so thank you. This is actually really good. We're closing out though on the last couple minutes.
Okay.
So I'm just gonna give the closing remarks.
You got it.
All right.
Just
So
stop streaming.
just let me share my screen last time. All right. So just to end off, slide. I was giving off the closing remark. So this book for resources you can read about. I used this book when I was getting started too. It's called Practical Malware Analysis. It's the one I used when I was also doing some teaching for my club. I really live by it. It's a little bit older, but it has a lot of relevant information. You can also get samples. Adam showed you Malware Bazaar, but there's also one called the Zoo on GitHub, where you can get samples to analyze them on. But just to close off, I just want to give some advice. I think some of the most important thing you can do, especially early on in your malware analytics career, is honestly less about doing the flashy, cool stuff, and more about doing the nitty gritty type of stuff. So this is getting used to reading documentation and research. And I've been, I'm saying it a lot because it's very important. And I'm 100% sure that's really what separates a decent guy from a really good guy. Someone who's willing to take the time to digest a lot of information. Um, for this. Is malware analytics for everyone? I would say it's for a lot of people. I think it's for a lot of people who think they don't want to do it, but they actually have the mind for it. I think if you love programming languages and you want to see some of the most coolest techniques you can get your hands on, I'd highly recommend looking at malware analytics and reverse engineering because you're going to be dealing with some of the best programmers who have been creating these types of malware samples to attack systems. And you get to see their techniques. Like I've seen techniques and see that I couldn't even imagine before. But because of the way they implemented in the malware, I had hands-on knowledge, and I think it's a very good skills level, especially as things are getting more and more automated. These are more resistant to automation takeovers in the job market because these are higher level skills to learn. So I think as you get going through your cybersecurity career, you can also get away from also looking at only log information from like a SOC or something, but also move towards, vulnerability research that this can lead to, or malware analytics, or anything that has to do with reverse engineering. So that's my advice on this. And I know I've, you know, gotten a lot of good stuff from this. So I hope you too can, this can be like a jumping point for you to start your journey. But thank you for listening to our talk. Um, I posted the slides on the in the malware analysis channel, and also the OVA file for you to import for VirtualBox. So if you want to have your own little virtual malware analytics lab that you can just start jumping on, there's some tools in there you can get used to, and so on and so on. Thank you.
Yeah, thank you guys for coming on. Like Philip said, if you guys have any other additional questions, you guys can utilize that malware analysis workshop channel and ask any questions. I'm sure you guys will be able to answer them through there if you guys are online, correct?
Yeah.
All right, awesome. Yeah, so thank you guys for coming on today, and thank you for partaking in JerseyCTF as well.
Thank you. Have a good day.
Take care,
Thank
guys.
you.